topic is topological sorting. Okay, what is topological sorting? What are the conditions we need to follow in topological sorting? I'll say. So in topological sorting, we need to follow DAG. So what is DAG? Directed Acyclic Graph. Directed Acyclic Graph. So what is directed? Directed means the graph should be having a directions. So that is called as directions. That is the arrow mark pointing. So we will call that graph as a directed graph. So what is acyclic? So I will explain with one example. Suppose 1, 2, 3 and 4. Okay. So this is 1. So this is a starting from 1 and say ending at the same point. So I am starting from 1, 1 to 2, 2 to 3, then again 3 to 1. So after completing all the points, I am returning to the same point, means that forms a cycle. So this is called a cycle. So but in topological sort, it should be acyclic. It should not follow a cycle. Then only we can find the topological sort. So we need to follow directed acyclic graph. Suppose this graph you take. In this graph, is there cycle formed? 1, 2, 4, but there is no direction from 4 to 1. Only 1 to 4 there is a direction. So this is an directed acyclic graph. So this graph only we are going to take for doing topological sorting. Okay, for doing topological sorting, what and all we need to follow? First, we need to find the in degree for each and every point. Okay, for example, I am going to find the in degree. In degree means I will say now what is that? In degree for 1. In degree means nothing but how many in degrees inverse arrow marks are coming to 1. How many inverse direction are coming to 1? No, there is no invert direction coming for 1. So the in degree for 1 is 0. Okay, this is how you will find the in degree for all the elements, that is all the nodes. Suppose for in degree for 2, how many in degrees are coming for 2? Only 1 in degree is come. So the for 2 the in degree is 1. Okay, for 3. So how many in degrees? ID is equal to, that is in degree is equal to 2. Then for 4 how many in degrees? 2. Then for 5 how many in degrees? 1. So this is how first we are taking they will give this graph. You need to find the in degrees. So for calculating the topological sort, first of all we need to calculate the in degrees for all the elements. Okay, now I am going to sort it out. Okay, so how I will find the in degrees, which is having the minimum number of in degrees. So see, ID 1 is having 0, 2 is having 1, 3 is having 2, 4 is having 2, then 5 is having 1. But which is having the least number of in degrees? 1 is only having least number of in degree. So I am going to eliminate this 1. Okay, so that only we can at last we can find the in degrees for that is we can find the topological sorting. So I am going to eliminate 1. So how I will eliminate? If I eliminate this 1, this arrow marks will be removed. This arrow marks will be removed. Okay. So if I remove this arrow marks, the in degrees also will be changed, right? Okay. So we first draw. We are eliminating this 1, this arrow marks. Okay. So the diagram will be like this. 2, then 4, 5, then this one. So now we are going to find the in degree for this one. Okay, I removed this 2 arrow marks. So now say how many in degrees for 2? 0 in degree. Okay, no in degree is there. So for in degree for 3 is equal to 2 in degrees. In degree for 4 is equal to 1 in degree. In degree for 5 is equal to 1 in degree. So once again, while calculating the in degrees, I will write the numbers. For 1 only I eliminated. So I written 1. So in the first step I eliminated 1. So I have written 1. So next step, which is having the minimum number of in degrees. So 0, 2, 1, 1, which is the least one. 2 is having the minimum number of in degree. So I am going to eliminate 2. Okay. So next step, so write this 1 comma, next I am going to eliminate 2. So I am writing 2 at this side. Okay. So now I will eliminate 2. So if I eliminate this arrow marks, what will happen? 3, 4 and 5. So like this only it will be the diagram. Okay, I am eliminating these two arrow marks. Understood? So what will be the in degree? 0, 1 and 1. So which is having the minimum number of in degree now? 4 is having the minimum number of in degree. So before eliminating 4, I will write in this result 4. So 4 we are going to delete this 4. So these two arrow marks will go. So what will be there remaining? No arrow marks from 3 to 5. Okay, see in the first diagram itself, no arrow marker. So here while writing there will be no arrow marker. So what is the in degree? No in degree or out degree. So the 0 will be the in degree. For this 5, again 0 will be the in degree. So now I am going to eliminate any one element. So I can eliminate 3 or 5. It's my wish. Okay. So I am eliminating 3 means, so in the result we will write 3 then 5. So the result may also be like this: 1, 2, 4, 5 and 3. After deleting 5 also I can delete 3. Okay, that is my wish. So in our example we are eliminated 3. So the remaining will be 5 and then we will eliminate all the elements. Okay, this is the simple method for calculating the topological sorting. So this is one example.